Okay, let's go ahead and solve for the V out of T of this differentiator op-amp circuit. And we want to notice two things. The first being that in an ideal op-amp, the voltage here at this node has to equate to the voltage here. So if this is 0 volts, this also has to be 0 volts. And the second thing we want to notice is that the voltage across this input capacitance, call it plus minus Vc of t, right? If we write an equation for it, so Vc of t is equated to Vn of t minus 0 volts. So Vn of t minus 0 volts. So that just means that Vc of t is equated to Vn of t. Okay. The method I'm going to use to solve for V out of T is called KCL. So that means then that the input current, so if this, I call this I1, that goes in here, has to populate and come out here, I2. So let me go ahead and write that. So I1 has to equal I2. And I1 through this capacitor is the input capacitance times the change or the difference in Vc of t over the change in time. And that has to equal to I2, which is 0 minus V out of t. So 0 minus V out of t divided by RF. And ideally, what I want to do is just solve for V out. So if I go ahead and do that, I just have to multiply everything by negative RF. So this becomes minus RF times Cn, the change in Vc of t over dt is equated to V out of t. And we said that Vc of t is simply Vn of t. So my final equation, RF, my final equation becomes RF times Cn, change in Vn of t over dt has to equal V out of t. In the comment sections below, please let me know what type of use case application you can use this differentiator op-amp circuits for. Thank you.